Hello, my name is Mike West. This short course is about a library in Python called NLTK. I hope you enjoy it.
This is the first course in a series of courses designed for learning a subfield of artificial intelligence known as natural language processing. In the course, we're going to learn a specific skill for machine learning practitioners who work with natural language processing. Natural language processing, or NLP for short, is used in a wide variety of text mining and sentiment analysis projects. In the course, you'll learn how to use a library in Python called NLTK to break down words into smaller pieces. NLTK stands for Natural Language Toolkit and is the industry standard for building NLP models. The process of breaking down text into smaller pieces is called tokenization, and it's one of the most fundamental parts to creating natural language processing models. Python is one of the most popular languages for machine learning, and NLTK is the most widely used tool for NLP. In the course, we will gently introduce you to the vernacular of machine learning and that of NLP. You'll get hands-on experience with the process of machine learning. This course is hands-on. We're going to learn how to define new terms and skip the math for now. Thanks for your interest in a comprehensive guide to NLTK and Python, Volume 1, and we'll see you in the course. In this lesson, let's discuss what we're going to learn in the course. The course title is A Comprehensive Guide to NLTK and Python, Volume 1. So the first thing we can gather from the title is that we're going to learn something called NLTK. NLTK is a library in Python used for natural language processing. A library in Python is no more than code that we can import that adds functionality to the core language. In our case, the core language is Python. Natural language processing is the ability of a computer program to understand human speech as it's spoken. NLP is a component of artificial intelligence. NLTK stands for Natural Language Toolkit. It's a very large library, so we're going to break learning NLTK into separate courses. The first course, we're going to focus on a concept called tokenization. The concept of tokenization is very easy to understand, but it's difficult to implement. Tokenization simply means breaking text into smaller parts. So in the course, we're going to use a library in Python called NLTK. This is the first course in a series of courses that will focus on the library. In the course, we're going to learn how to break up text into smaller pieces. All right, let's get started. All right, in this lecture, let's talk about what tokenization is. Tokenization is very easy to define and understand. It's more difficult to implement. So it's the process of breaking up a piece of text, now that's the key word, into many pieces. Down here, you'll see this is actually an example of tokenizing a paragraph because we have two sentences. We can actually also tokenize a sentence into its distinct words. All right. So tokenization is not specific to words or sentences or paragraphs. It's really just the process of breaking up text into different structures. Right? Let's talk about the code. So from what? Anytime we see this, we know we're bringing in only a piece of the library from this thing that we're going to talk about throughout the course, from this library. This is our library, and it's called NLTK. Right? Tokenize. We're going to bring in this thing called tokenize. Import what? Import sent tokenize. Well, what's that? It's just short for sentence. So actually it really should be, instead of sentence, this really should be para for paragraph. Right? Because what we're really doing here is separating a paragraph into disparate sentences. All right, so all we do is create this thing here called a variable. And all a variable is an empty container for our paragraph here. That's all it is. So we're going to use sent tokenize, right? This thing we brought in up here, this object from NLTK to tokenize what? To tokenize the sentence. Actually, what we did, let's change it. We didn't tokenize the sentence, we changed it to a paragraph because we've got a paragraph. So para, right, to tokenize that paragraph. And it did that. When we hit Control Enter, we put our cursor in the cell here, and we hit Control Enter, it did exactly what we asked it to. It tokenized our paragraph into 2 sentences. Right? That is the very basics of tokenization, and it's what we're going to be talking about in an in-depth fashion in this course.
In this lesson, let's define what predictive analytics is. Predictive analytics isn't hard to understand, at least at a very high level. Let's take a look at an example of where you use predictive analytics in your everyday life. You're at the grocery store, you're done shopping, and you're ready to check out. Your brain starts to run a built-in predictive algorithm with these parameters. The expected output. What's the fastest line? That's the one you need to pick. Target variable. The time spent in the line. The less, the better. What's the fastest way to leave the shop and go home? Historical data. Your past experience from previous shopping sessions. Predictors or features. The length of time, the number of items in the basket, the average age of the people in line. The predictive model. The one that your smart brain picks. Basically, computers do the exact same thing when they do predictive analytics or even machine learning. They copy how the brain works. Obviously, computers are more programmatic. They use well-defined mathematical and statistical methods and much more data. However, you and I do predictive analytics every single day.
All right, in this lesson, let's go ahead and install Python. Now, when we install Python, we have 2 options. We have an older 2x version and we have a 3x version. Most of the time, especially if you're in the Windows world, you want to go with the newest. However, in the applied machine learning world, Python 2x is still used heavily. So oftentimes I'll install 2x. For this video series on NLP, we're going to go with 3x. We go to a search engine, we type in Python, and we type in Anaconda, and we hit enter. And the first one should be where we want to go. Download Anaconda. Well, let's go look and see if this is the right page. This is it. Anaconda from Continuum Analytics has bundled both versions for us. Here's 4.3.1. Let's see. The 3.6 version and the 2.7. We want to go for this series with the 3.6 version. So let's go ahead and install that. No thanks. Appreciate it though. All right, we finished downloading. It took about 2 minutes. Let's show in folder. Go on folder. Let's show in folder again. All right, for whatever reason, that's not behaving. All right. Oh, here we go. I clicked on it to run and it says let's run it. All right, well, go ahead, let's run it. Sure. This is really slow and this is a fast laptop, so this is really strange. All right, here we go. Anaconda, yep, thank you. Next. I agree. Nope, every user's me. Sure. Yep, that looks great. Yep. All right, so we've got it completed. That took a few minutes. All right, let's go ahead and open. Let's type in Anna for Anaconda prompt. Anaconda. There's the Anaconda prompt right there. Let's hit enter. Let's pull this to the middle. Jupyter notebook. Let's open a Jupyter Notebook by typing in Jupyter Notebook. And there we go. New Python 3 notebook. All right. All right, so we're not done. We've installed it successfully. Now we need to go install NLTK. All right, now we need to install NLTK everything. Now, what's everything? Well, there's this kind of fork. You've got the data, and you also have the modules. We want both, and this will do it. So when you download the items for the course, this will be a Jupyter Notebook you simply place into the default directory, load it, and here we go. So in order to do it, we're going to copy this, Control C. We're going to open our Anaconda prompt. To do that, we go into our search, type Anaconda, hit enter. Our Anaconda prompt will load and then paint. There we go. We'll hit Control V on the keyboard if you're a Windows user, and then we'll hit enter, and it will begin installing everything. And there we go. And it will get to this one point where it says, let's see, give it a second. There. This is going to take a while. I downloaded it. We have a really fast pipe at work, so I downloaded it at work, and it eventually does work, but it takes a little time. Once this is finished downloading, we'll get the prompt and we'll be done, and we'll be ready to start tokenizing our data.
All right, in this lesson, let's learn about the Jupyter Notebook. The Jupyter Notebook is our IDE. An IDE is an integrated development environment. It's where we're going to write our code. How do we get there? For Windows, let's come over here and type in CMD and hit enter. And let's type in Jupyter Notebook and hit enter again. And now we're going to get the home page. See, it says home, and it's a URL. And in order to open up a clean notebook, we come here and we come here, we navigate to Python 2, and we hit OK. And this is a cell, and this is our Jupyter Notebook. So the first thing we want to do is let's name it. So we just click on that. Just actually double click. It brings up this dialog box, and we'll call this our first, I was going to say Python notebook. We'll say OK. And now we can see it's changed the name to our first Jupyter Notebook, right? So this is a cell, and this is where we type our code. A nice thing about this is we can also document what we're doing. So notice here it says code. If we change this to Markdown, and we come down here, and let's type in, how about a pound sign to make it a nice large header. Then we'll say, let's get started. Let's get started. And every time we want to execute a cell, we hit the control button and the enter button. And now that's run successfully. All right, now if we want to come up here and run some code, we go to the next cell. This adds a cell. And when we're highlighted here, we don't want the cell, we just delete it. We cut it. The scissors gets rid of it. All right? Let's write some code. Let's import pandas. Pandas is a library as PD. We're going to import pandas. We're going to alias it here as PD. So all you have to type in as PD to be able to use panda. Control again, enter. It's running. You can see the little asterisks, and now it's finished. You can also run your code up here. Let's put that there and hit the enter. And it will execute and move to the next line. We can move our cells up and down. All right, so let's put our highlight there, and let's move the cell down, or move it up in that case. Let's move it down, and now we can type something else in here. Let's type in some more documentation. The import means the word import means to bring in to Python, to bring in a library into Python. All right, Shift Enter, and there we go. All right, so what are some other things we can do if we wanted to stop? We're executing some code and it's taken longer than we anticipated. We could come up here and hit the stop button. Right? We can insert. If we didn't want to add, we can highlight our cell, right, and insert above or below. Right? Let's come up here and type something. Let's say backspace 1 plus 1 plus 2, 1 plus 2, and we hit Shift Enter, and it gives us the output. Now, let's say we've done this the whole way down. We've got a big long list of code, and we want to clear the output. So let's come up here to Cell, Current Cells, Clear. Current Output, Clear. And that will clear all of our cells. And I promise you'll use that later. That's really a handy feature. All right, we can save anytime you want. This is kind of like forcing a save. It will auto-save every few seconds as you're working through the code. But again, you can force a save anytime you like. All right. Let's move back to the home page for a second. We have what we can see on our home page what notebook is running, or notebooks. So let's come down here and we can see our first Jupyter notebook is running. So we can highlight on this, right? Click on it, and we can come up here and we could shut it down, turn it completely off, and we could delete it. So let's go ahead and shut it down. Let's go ahead and open it back up. And it'll open up from scratch. Let's say we did this. Let's go Control Enter. This is how you're going to execute if you don't want to continue to hit this all the time. Most people will hit Control Enter. So let's go ahead and Control Enter. And there's 3. So this looks like it's run. And if we were to shut it down, right, it may save this for us. However, if we have a whole bunch of code and we start this again, each cell will have to be run, right? Once we close this window, right, this is our Python server. We close this, it shuts everything down, right? If we come up here and we see this, just like this, it's not been run, it's not been executed. You're going to have to step through the entire process again, right? Or you can run all the cells up here if you like, right? All right, so let's recap. So these are cells, right? In cells, we can type text. We have to come up here and say markdown in order to type some text in here, right? This cell, we have code, and it says code, so we can type some code in there. We can hit Control Enter to execute. We can also hit this little button here to execute, and that'll take you to the next line, right? If we want to come up and cut a cell, we use the scissors to cut a cell. We can easily add a cell by hitting the Add Cell. And if we want to save our entire workspace and we want to force the save, it's called a checkpoint, we hit the Save button. Right? If we want to clear our screen, we come up to Cell and Current Cells, and we clear all the cells. Right? As we go through, I will show you some more hints to work with our notebook, but that really is about it. That's all we need to know to get started building our model.
All right, in this lesson, let's demo some tokenization in Python. So we're at our home page, and we know that because up here it says Home. Then we go to New, and we say Python 3. That opens up a new Python 3 notebook, and we're ready to go. So what's the first thing we want to say? How about some comments or a comment? Now, I don't like a lot of comments because I think they distract from the code. But it's a really good idea if you're sharing your notebooks with a team, or if you just want to put something in there to go, oh, that's what that's for. The comment simply means that the compiler ignores it. So let's I can't spell, tokenize some, or hey, we're only going to do one. Let's tokenize some, S-E-C-N-T. Now, let's write some code to do that. From what? From NLTK. That's our library. Tokenize. What? Import what? Import the sent tokenize. That's actually going to do the tokenizing. All right, so let's go sent. Let's just type it all out. Now, this is a variable. We can call it anything we want. S-E-N-T and sentence is equal to thanks for taking my course. NLTK rocks. Have a great day. Cool. Next line of code. Let's actually get some work done by using this sent tokenize. All right, so control copy, control V, right? Sent tokenize what? The sentence. So we've got some parentheses and we type in sentence. And then we hit enter. And we've indeed broken up our sentences or our paragraph here into separate sentences. All right, let's add another one. This little button here does that. Let's go and tokenize a word. So what do you think we're going to do? The same thing. From what? From NLTK dot tokenize. Tokenize what? Import. How about the word tokenize? Makes sense, doesn't it? You know what? I didn't have a comment, so let's come up here, put our cursor there and hit enter. So pound sign, and then now let's say let's tokenize some words. All right, the next thing we do is let's go and tokenize our sentence from above, right? So how do we do that? Well, we just go word tokenize, right? On what? Control copy. Now, all right, so let's copy this. Control C, Control V, and tokenize what? Open close parentheses, sentence. So now we've taken these 2 or 3 sentences and broken them down into words. And each of these words is a token, right? Let's go ahead and clean this up. Let's get rid of the output, I mean. So to do that, we go to cell and we go to output, clear it. Now we're clean. Let's go ahead and add, right there, another cell. All right, now let's try the word tokenizer. Let's go word.tokenize with a contraction. Tokenize, tokenize, open parentheses. Don't is a contraction, period. And that's not what we want, is it? I mean, it does it. It tokenizes the sentence, but it doesn't give us what we're expecting. So we know that this word tokenizer doesn't do so well with contractions. Let's go ahead and bring in one called word punct tokenizer that should. So let's go here. Let's cut our cell. We do that with the scissors. Let's add another one. Boink. And let's bring in. All right, so we could add a comment, but let's skip that for now. And let's just, come on, where's my cursor? And let's just type from NLTK dot tokenize. And we're going to bring in something new. We're going to import the word capitalized there. P-U-N-C-T, that's capitalized. Tokenizer. All right. Let's go, let's see if it works first. Let's hold Control Enter. And it works. Control Enter. And let's go Enter. Tokenize equals what? Equals word punct tokenizer. Control copy. Control V. Let's go Enter. Now let's go tokenizer. Tokenizer dot tokenize what? Tokenize something with a contraction in it. Don't is a contraction. So again, not what we're looking for, but it did tokenize the apostrophe, right? You can see we have Don, right? There's the token. The apostrophe is its own token. The T is a token. Again, we asked to tokenize with punctuation, and it did. It tokenized the punctuation also. Again, not what we're looking for. So how do we get around that? Well, we have to resort, and you often have to do this in the real world, to something called a regular expression. And regular expressions can get finicky, and they're not a lot of fun, but they really give us a fine grain of controlling our tokenization process. All right, in this lesson, let's take a quick look at two regular expression tokenizers. From a library, we're importing tokenize like we've seen everywhere else, and here we're importing the regular expression tokenizer. All right, here we are saying tokenize, regular expression tokenize, with W, and the with W simply specifies the optional internal hyphens and apostrophes, which we'll see in a second. So here we are, don't is a contraction. Let's see if it splits up don't correctly. And it did. That's what we're looking for. Notice that we've tokenized the sentence into the correct number of words or tokens, right? We have 4 tokens, but the don't keeps this apostrophe. All right, here's a little more complex example. Here we have some dollar signs, numbers, and a whole lot of other stuff. Let's see if it can tokenize this with a regular expression. And indeed has tokenized the entire sentence into, it looks like, the correct number of words. Right. Let's put an apostrophe in here and see if it catches it. Now obviously that's not right, but we don't care. We just want to see if it tokenizes it. It did not. Right? So instead, it split it into its own token. Right? Not what we're looking for. But either way, we've got 2 examples here where we can see the power of regular expressions, and also, look at this string, isn't that fun? We can see the complexity involved in regular expressions. All right, in this lesson, let's talk about stop words. What are stop words? Stop words are words that don't have any meaning that we want to get rid of. How about A? A is a stop word. We don't want it. We need to get rid of it. How about the? The is certainly a stop word we can get rid of. How about love? No. All right. We want to keep. That has meaning. Let's go see a demo on stop words and how we remove them in NLTK. All right, so now that we know what stop words are, let's go ahead and filter some out. So what do we want to do? We want to do from. We're going to bring in a corpus, and NLTK dot corpus. We're going to import some stop words. We're going to look at the stop words in English. All right, so we've got a few. Let's go ahead and add a cell. Let's go ahead and get a complete list of the stop words in the languages supported. Stop words dot file IDs, and let's hit enter, and we've got a few. I wonder what they look like in like Hungarian. All right, so we've got a few. All right, let's add another cell, and let's go ahead and take a sentence and filter out the words. So from our usual NLTK dot corpus, import stop words. Let's go ahead and ENG stop. We need a variable to hold our stuff. Let's go ahead and set that variable to stop words dot words dot SH. All right. Let's go ahead and words. What words? Well, words equal these words. Open brackets. Can't. Is a contraction. Open bracket. Word for word in words if word, little if statement, not in English, eng stops. And I didn't like something, or this corpus reader object has no object. Words. See, you got to spell it right, don't you? No one told me that I was spelling it wrong. Can't, contraction. So we can see it stripped out all of the stop words. All right. All right, in this lesson, let's cover WordNet and let's cover synsets. WordNet is a dictionary designed for NLP. NLP is you and I. And NLTK, our library of choice, comes with an interface for WordNet. That means we can use WordNet to do a lot of lookups. Synonyms are words that have similar meanings. All right, that's great. A synonym set, or synset, is a group of synonyms. All right, now we're going to make a graphical representation of this. But first, let's go through some of the basics. So we've seen all this before, from what? Text blob. Text blob is simply another library here that we can bring in, that we can also use with WordNet. We're going to bring in word. You've seen this before. There's our variable. And we're going to look up plant. All right. What are synonyms or synonym sets for plant? And here are a few. Our synsets are broken down into 3 distinct areas. The name, right, there it is. There's our name of the word. There is our part of speech. What is it? It's a noun. And which definition is it? Here we have a total of 5 definitions. 1, 2, 3, 4, 5, right? Most of them are nouns except for one down here, and he is a verb. All right, so give them to me. Word definitions, all 5 of them. That's pretty self-explanatory. And here they are. Buildings for carrying on industrial labor, and botany, living organism, an actor. All right, that's what we want. We're going to work with him. Use the living organism one for our example. So give me the sysnut in position 1. What is our plant hypernyms? All right, so we've got 2 key terms there, right? Let's put it down here. We've got hypernym, which is right here. And a hypernym is synsets that are more general. So these are more. On the other hand, we have hyponyms down here. So we've got 2 new words here. We've got hypernyms, number 1, and hyponyms. And these are, what's the definition? Equals more specific or more granular. So let's draw this out in graphical form. So at the top here, we have what? We have the organism. It's specific. An organism is a what? It's the plant. Why? Because that's the organism we're talking about. Organism, think, is a plant. Now down here, right, we're moving from, remember what we're doing? We're moving from less grain to more grain, to more granular, right? Over here, this is hyper, and these are going to be hypos down here. Hypos. Organisms of plant. Let's go over here, and we can see what are some hyponyms for organism. Acrogen. No, I don't know what that is, but it is, so we're going to put acrogen. How about next? Air plant. Well, I know what an air plant is. Air plants. These are hyponyms. And how about it's aquatic? All right. I believe the graphical representation here will make it easier to understand the relationship between the words, right? Because this is how it's laid out in WordNet, right? Which is our NLP dictionary. All right. All right, in this lesson, let's learn about lemmas. And that's how you say that. Say Emma, Emma, and then put an L in front of it. When I first started reading about this, I wanted to say lemmas. All right, it's not. Say lemmas. All right, so what's a lemma? A lemma, right, in WordNet, which is what we're talking about, is an entry in a dictionary. It's a word with a single meaning, right? So if you looked up banks, then the form would be bank, right? All right, it's important to understand that there would be separate lemmas for each of the definitions, all right? Now, what's that mean? Let's come down. Let me show you. First, let's talk about the code. This we've all seen before. We know what we're doing here, right? The only tricky part of this, we all know this code, is this, right? And this isn't tricky. It's this part that always gets me, all right? This is the what? This is the second, right? Word right there for plant. It is not the first. Why? Because the first would be 0, because 0 counts. All right, so for this lemma right here, we have 3. Come over here. 3 lemmas. What are they? Plant, floral, and one we can't see down here because it's not on our screen. We'll see when we take a look at the code. So I gave you another example here. You can read about it, right, if you like. But this right here is the core, right? It really is just a entry in a dictionary, and the key part is that there is going to be lemmas for different synsets or different definitions. So each of these, right, each one of these is going to have different lemmas, right? This one corresponds to the one we're working on because we've put that here. We said we want the second lemma in WordNet, right? Let's go take a look at this in the code. All right, so let's take a look at the code. Remember we said this is in the second position. Well, what's in the first? Well, what is in the first is, the plant, like a place where you work. And it has 3. So what are those? Plant, all right, control enter. All right, well, plant's one, right? Works is one, and industrial plant is one. All right, what's in the third position? Which is really two. Let's go control enter, and we'll say control enter, plant, yep. Index here. Oh, there is only one. So you'll get this if you're taking a look at the different lemmas, because this is out of range, because there is only one. So it's saying, listen, I gave you the first one, right? The first one was 0 that you asked for here. This is out of range. There's not another one. All right. How about, how many do we have? Let's go with the fourth one, right? The fourth synset. So we type in 4 there. Let's see how many. 2. Well, what are they? Let's go with 1 and 2. Plant. All right. And set. All right, so I think we have the idea of what lemmas are. The idea isn't that difficult, the concept, but it's kind of confusing to look at it in the Jupyter notebook. All right, in this brief lesson, let's go over antonyms. Synonym, same. Antonym means the opposite. So some lemmas also have antonyms. So here we define our variable. And remember the three part, the name of the word, the part of speech, and the first definition. All right, so what's the definition of the word hate? Let's go control enter. WordNet is not defined. That means we have to define it. Come up here, control enter. Little asterisk means it's running. Now it's defined. Let's come down here and execute it again. The emotion of intense dislike. All right, so we know what hate is. So down here, the ant of the lemma, antonym of the lemma. All right, so what's the antonym here of hate? Right? Control enter. Love. Love is the opposite of hate. All right, so we did that, and down here we got the opposite of hate, right? Because it's the antonym here. So what's the antonym that we've specified here? Remember, this is just a variable. And a definition of a variable, a strong positive emotion of regard and affection. All right, so it's a brief lesson on antonyms. Now, I would like to mention that you're going to get this, and I keep saying this, I'm sure, this entire notebook. But if you just come through here and put your cursor in there and you click enter, and that's how you try to learn through these, it's probably not going to work for you. All right, you actually need to, if you're fortunate enough to have a separate computer, put this notebook on a separate screen and you type all the information out yourself. If not, just print this out, right, and then type it out yourself. You are only going to learn this if you get your hands dirty and you start writing the code. All right, in lesson 5 here, let's learn how to calculate WordNet and SynNet similarity. So synsets are organized into a hypernym tree. The tree can be used for reasoning about the similarity between synsets, right? Let me show you what one looks like. So at the top are like living things. So all living things can fit into two categories. Plant or animal, actually creature. All right, well, what kind of plants? Vegetables, flowers, we'll call that flower for short, and tree. Creature, let's make this a little longer to give me some room. Animal, pig, dog, cat. So in creating synset similarities, the closer these two are, the greater the similarity. The further away in this hypernym tree, the more dissimilar they are. So up here, let's go take a look at the code. We've seen this before. From our corpus, we're going to import WordNet. we're going to create a variable called height. And here it is. Remember, we need that three-part convention, right? Don't forget that, the three-part naming convention. The name of the word, naming convention, and that's the name of the word, the part of speech, and the place that it is in terms of the definition, or how many definitions there are. Discussed, right? What we're doing is creating another variable. We've got two words, right? Hate, first word, second word, discussed. And all we're doing is doing the same thing. Hate, WP, whoop, similarity, discussed. So how close are they? And our hypernym tree determines their similarity. So down here you can talk about the swap similarity to find out what it is. Here we can see they are 71% similar. So in WordNet, the similarity between hate and disgust, between these two words, is 71%. All right, let's go take a look at this in the code. All right, so we've seen hate and disgust and the similarity between the two. All right, so let's go down and take a look at dissimilarity. So here we did the same thing, right? Hate and frog. All we did is define a variable for hate, a variable for frog, and use our three-part naming convention for the word. So what is the similarity between hate and frog? 11%. All right, so they are highly dissimilar. All right, in this lesson, let's talk about discovering word collocations. I do love the words in this field. All right, so what's a collocation? Two or more words appear frequently together, such as hot dog or United States. Right? So for collocations, the context will be a document in the form of a list of words. Right? Well, that makes sense. So what we're going to do is find common phrases that will occur frequently together in our text. All right? Now, this thing is really going to do the work, and he's called a bigram collocation finder. All right. Again, you've got to love these words. Now, bigram means what? Two words. Two words. All right. Collocation here is the act of hunting for words. And finder means to find. So what are we doing? We're trying to find words that happen together, right? How many of them? Two of them, all right? The bigram, two, collocation finder. All right. So down here, I just have another definition. This is actually a more succinct definition. Two words that are adjacent to one another. All right, let's look at this sentence. And I spelled courses wrong. Gee whiz. All right, so I really love Mike's courses. So what are the bigrams in that sentence? All right, so I really, really love and love Mike's. All right, so we have a total of 3 bigrams in that sentence. All right, now they'll have different weights, right? So what our tool here is going to do is look for a weight, right? So I really and really love and love Mike's are going to have different weights, all right? Love Mike's is probably not going to be found that often in our dictionary, all right? Really love is probably going to be found the most, all right? Or maybe I really, that'll be number 1, that'll be number 2, and this will be number 3, all right? So they're going to be weighted, all right? Let's go take a look at the code. Down here, we have the same NLTK, right? That is our library. We're importing stop words, right? Stop set. Here we're setting this variable, right? This is our var. And what are we doing? We're putting in the set of English stop words. We're going to filter our stops. Again, another variable. Lambda. Lambda is simply another word for function. All right. So let me give you a simple lambda. Let me come down here. Where's my little mouse? So f equals lambda x, we'll define x, is equal to x plus 1. Right, this is a lambda expression in Python. Right, so what is f3? Right, so the lambda function, we know this x is x plus 1. So our answer here would be 4. So don't let this lambda expression up here scare you. So in this line, we're going to apply our word filter to filter stops, right, to this variable here. And then we're going to find the bigram association measure with the likelihood ratio of the top 4, right? So what are the top 4 bigrams in this text? And this text happens to be, I think, Monty Python. All right. I'm not exactly sure what body of text it is, but we can see in that text, right, these are the top 4, right? Black Knight, Clop Clop, Head Knight, and Mumble Mumble. So that is a high-level overview of what bigrams are and what collocation is.
Now, if you're interested in becoming a machine learning engineer, I have a short course down in the description, down below. That's $9.99. That will provide you with some real-world advice on becoming a machine learning engineer. Thanks for watching. Subscribe, hit the little bell, and we'll see you soon.